An optically active compound rotates a plane of polarized light. How is this related to a maze runner? Optical activity has to come from somewhere, so stop the video and review the stereochemistry and reactions ideas. Here's an example. Butane and Cl2 are both achiral. Neither compound has a chirality center. Both have a plane of symmetry. This reaction, however, produces a chiral product, but the product mixture is racemic. A racemic mixture forms because the radical intermediate is chiral. So stop the video and answer these two questions. Here are the answers. The shape is, and here's how Cl2 can react. If Cl2 reacts on the top side of the radical, one enantiomer forms. If Cl2 reacts on the bottom side of the radical, the other enantiomer forms. The alkene halogenation reaction also produces a chiral but racemic mixture of products. So stop the video, take a look at the mechanism, and determine the configuration of each chirality center. Then explain why the product is racemic. So here are the answers. You will get a 50-50 mixture of each product because the bromide has equal access to each carbon in the bromonium ion intermediate. In the previous slide, cis-2-butene plus Br2 gave a racemic product. Will trans-2-butene plus Br2 also give a racemic product? Stop the video and figure that out. I'm sure you reacted the bromide at one carbon or the other. Next, determine the configuration of each chirality center. Now, it looks like these two compounds are enantiomers, but it turns out these are mesocompounds, which means they're the same. Look for a plane of symmetry or rotate one of the molecules so it looks like the other. So let's practice. Stop the video and answer these questions. Here are the answers. The carbocation intermediate is trigonoplanar. So the bromide ion can react either the top side or bottom side of the carbocation. For the second reaction, the product is optically active if the mechanism is SN2. Remember, in the SN2 mechanism, there's inversion of configuration. For reaction 2A, each reactant is achiral. The product has a chirality center, but you'll get a racemic mixture. For reaction 2B, 3-methyl-1-pentene has a chirality center. This means that compound is optically active, therefore the product will be optically active. We would see a racemic mixture at one chirality center, that is the carbon bond to the bromine, but carbon 3, the original chirality center, will still be optically active. For reaction 2C, 3-methyl-3-hexanol has a chirality center, so if a substitution reaction, the product will be optically active if the substitution mechanism is SN2.